All right, so I'm gonna do this next problem using StatCrunch. I try to get them so that I can do this side by side. Something weird is happening. Okay. So according to the study of U.S. homes that used heating equipment, the mean indoor temperature. So here's my claim. The claim is that the mean indoor temperature at night during the winter is, the mean is 68.3. Okay, that's the claim. All right, it contains equality, so that is the null hypothesis. Okay, the opposite of the mean being 68.3 is that it's not 68.3. And since this is the one that does not contain equality, it is the alternative hypothesis. Okay, since the alternative is not equal, this right here is going to be a two-tail test. So that means that our alpha right here is going to be divided into two sections. Okay, on the two-tail test. When we have a two-tail test, this right here is not all of alpha, it's half of alpha. So we've got to take 5% and we've got to divide it into two pieces. So each piece gets 0.25%. Okay, so this right here and this right here each have an area of 0.025. This is 0.025 and this is 0.025. And we do have two rejection regions. So we do need to find our our critical value. Sorry, we need to find our critical value. Our critical value is going to be, I'm going to go to StatCrunch to do it. Do stat. I'm going to do calculation. I'm going to do normal. I know my area is 0.025. And you can calculate this one right here, negative 1.96. Or if you want to do the other side, you have to do 0.025 over there. And it's a positive 1.96. So this z is negative 1.96, and this z is positive 1.96. Okay, that's our critical values. All right, now let's finish writing. It's also our rejection regions, right? This is our rejection region. So you think this information is incorrect. You randomly select 25. So my sample size is 25. That's not big enough. So they better tell me that my population is normally distributed. And they tell me that right there. So they tell me my population is normally distributed. I only have a sample size of 25. So this picture is still valid because they told me it was normally distributed. Okay. 25. And you find that of this 25, the sample mean is 67.2. From past studies, the population standard deviation, that's how I know that I'm going to get to use my z-scores. The population standard deviation, that's how I know it's a z-test. It's a z-test because of this. Population standard deviation is known to be 3.5. And then alpha. Okay, so we've got that going over there. All right. So what are we going to do? Let's go over here to, don't need this anymore. Let's go to Z stats. Why Z stats? Because we have it's a Z test because we have the population standard deviation. So we're going to go over here to Z stats. And it's always a one sample, and we're doing it with the summary. The sample mean, that's 67 point, okay, 67.2. The standard deviation is 3.5. The sample size is 25. This time our our null hypothesis is 68.3. And our alternative hypothesis is not equal to, so we didn't have to change that. I did, after I stopped the video last time, I went back and looked at that, and that is a good picture. So I'm going to go ahead and compute, and they give me a test statistic of, and I'm going to change my color. Let's change it to, I'm going to do my test statistic of negative 1.57. So here's 0 right here. A little fat. Okay, and this is negative 1.96. So we know that negative 1.57 is not going to be over as far as negative 1.96. So my z-score is not in my shaded section. So since my z-score is not in my shaded section, this, remember, is the rejection section. This is the rejection section. It's not in the shaded section, so we're not going to reject it. And if we do not reject it, we just simply say that we fail to reject. Fail to reject H sub O. Okay, now we can also determine, we did that by the rejection regions, that the test statistic, as you can see over here, negative 1.57, is not in the rejection region. So that means that we're going to fail to reject. We can compare P to alpha. Okay, our alpha is, I don't know if I'm supposed to put 0.05 right here. 0.05, or if I'm supposed to put 0.205. Well, we'll see. If it's wrong, then we only put the half. But anyway, so we'll put alpha right there, and the P is 0.1161. Okay, it's going to work because this number right here, 1161, is much bigger. That's like 11 cents. This is 5 cents. So this is greater, or P is greater than alpha. So what happens when P is greater than alpha? P is greater than alpha. What do? We fail to reject. So again, we failed to reject. We failed to reject because of the rejection region, and we failed to reject because P is greater than alpha. Okay, so we failed to reject both times. Now, how do we determine what our sentence is? Okay, so you go back and you see my claim is my null. My claim is my null, and I failed to reject. So here's my sentence. There is not enough evidence to reject the claim. There is not enough evidence. Oh yeah, there is not enough evidence at 5% significance level to reject the claim. To reject the claim that the average indoor temperature at night is 68. The average indoor temp at night is 68.3. So that would be the conclusion. There is not enough evidence at the 5% significance level to reject the claim that, so there's not enough evidence to reject the claim. So some of you might be picking up on the fact that if there's not enough evidence to reject it, then that means that we can support it. Now, some people are going to argue that that's not the same thing. Again, I'm almost about to forget to go over and show you, but I'm show you that here they're showing you that with this thing right here, we can see that this is at 1.57. That's where that is. And we know that 1.96 would be a heck of a lot closer to 2 than that one. So again, we could see that this right here is not going to be in that original rejection region. So I don't know what that was, but anyway, so that you may like to see that right there. Then again, you may not. May be better to look at it over here. Okay, so that's how you use StatCrunch. Now, remember, the other thing you could do would be using the table and these formulas that we use at the beginning. You could be using this formula right here and looking up your test statistic and your critical value. You could be looking that up on your table and then drawing your conclusion that way. So the rest of the examples that I think I'm going to do, definitely this one. And I probably won't do all of them. I will post my answers because that's just more practice for you to do. But I will do this one. I'll probably use the calculator, maybe 2 more. I'll do 2 more, each one on the calculator. And then I'll leave these for you to practice and I'll post my answers in the teacher notes. Okay.